This is a sophisticated use of the calculator to solve differentiation questions. Make sure you've watched the easy version first. So this one wants us to find the x value where this function has the gradient of a half. So the obvious thing to do is to plot it. So we'll do that. Looks lovely. Go to Sketch, Tangent, and I can search along here for when the gradient is equal to a half. You see it's equal to 0.48 there, 0.50. Maybe it's between those two. Well, it is between those two. Notice the way the x value is going above 1 and below 1. So maybe it's exactly 1. Well, I can type the number 1. Let's type it. I've got it. X equals 1, dy by dx equals a half. Lovely. Notice there's another place somewhere up here where it's equal to a half, about there. So obviously that's not a very satisfactory way of doing it. Let's go back to menu 1 and let's have another look at the question. We can rewrite this question with sophisticated notation. D by dx, the gradient of this function when x is equal to a is equal to a half. If we can solve that equation, we are done. And we can type this exact equation into solve_n. Let's do it. So solve_n, d by dx of the function that I've already typed into the graph. So I'm going to go to variables. That is here, variables. It's one of the graph variables, y, and it was the first one. That saves me from having to type it in. Now, I need to type in some x value here. Well, let's use the button that is used for all x and y values. All theta t, that's why the button is written like that. It's just saying it represents everything. So I'm going to type that button. And I know that looks odd. And that's equal to a half. Close the brackets. And let's run that. Now, first of all, have a look at this notation. This is saying d by dx, the gradient of the function in y1, when x is equal to a half. And it's going to find me those x values. 1 or 3. Lovely.